Okay, so once again, good morning. So this time we're going to have a discussion about the frequency and percentage distribution and ranking, order ranking. Ranking distribution, of course, cover the some discussion about percentile and percent ranks actually, no? There are certain consideration about the calculating of percent ranks and so on. Okay, so to give us more details about the frequency and percentage distribution in order ranking, let us all welcome our presenter.
Good morning, Dean. Good morning, classmates. Today, I will be reporting distribution and central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within the set of data. As such, measures of central tendency are sometimes called measure of central location. They are also classed as summary statistics. The mean, often called the average, is the most likely measure of central tendency that you are most familiar with. But there are others, such as median and the mode. The mean, median, and mode are all valid measures of central tendency, but under different conditions. Some measures of central tendency become more appropriate to use than the others. In the following sections, we will look at the mean, median, and mode and learn how to calculate them and under what conditions they are most appropriate to be used. In a normal distribution, data is symmetrically distributed with no skew. Most values cluster around the central region, with values tapering off as they go further away from the center. The mean, mode, and median are exactly the same in a normal distribution. What is skew distribution? A skew distribution, more values fall on one side of the center than the other, and the mean, median, and mode all differ from each other. A positively skewed distribution, there's a cluster of lower scores and a spread out tail on the right. While negatively skewed distribution, there's a cluster of higher scores and a spread out tail on the left. Measures of central tendency. The mean, or average, is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data, although its use is most often with continuous data. The mean is equal to the sum of all the values in the dataset divided by the number of values in the dataset. The mean is essentially a model of your dataset. It is the value that is most common. You will notice, however, that the mean is not often the one of the actual values and that you have observed in your dataset. However, one of its important properties is that it minimizes error in the prediction of any one value in your dataset. That is, it is the value that produces the lowest amount of error from all other values in the dataset. An important property of the mean is that it includes every value in your dataset as part of the calculation. In addition, the mean is the only measure of central tendency where the sum of the deviation of each value from the mean is always zero. However, the mean has one main disadvantage. It is particularly susceptible to the influence of outliers. Outliers are values that are unusual compared to the rest of the dataset by being especially small or large in numerical value. Median. The median is the middle score for a set of data that has been arranged in order of magnitude. Median is less affected by outliers and skewed data. To compute for the median, let us assume a set of numbers arranged in order of magnitude. In example 1, Our median mark is the middle mark, in this case, 56. It is the middle mark because there are 5 scores before it and 5 scores after it. This works fine when you have odd numbers of scores. But what happens when you have an even number of scores? What if you had only 10 scores? Well, you simply have to take the middle two scores and average the result. So, 55 plus 56 is equals to 55.5. The median is 55.5. Another measure of central tendency is the mode. Mode is used to represent a set of values when it is clear that one value predominates the others in a set of values. Mode is the most frequent score in dataset. Normally, the mode is used for categorical data where we wish to know which is the most common category. The problem with the mode is that it will not provide us with a very good measure of central tendency when the most common mark is far away from the rest of the data in the dataset. The mode is the most frequent score in our dataset. In Figure 1, the mode represents the highest bar in the bar chart or histogram. You can, therefore, sometimes consider the mode as being the most popular option. In Figure 2, the mode has a value of 2. We can clearly see, however, that the mode is not representative of the data, which is mostly concentrated around the 20 to 30 value range. To use the mode to describe the central tendency of this data set would be misleading. Among the three measures of central tendency, the mode is the measure seldomly used. Mode lacks uniqueness and sometimes it does not exist in some cases. To summarize the measures of central tendency, the mean is the average. To find the mean, you add up all the numbers and then divide by the number of numbers. Note that the mean isn't a value from the original list. This is a common result. Do not assume that the mean will be one of the original numbers. The median. The median is the middle value in the list of numbers. To find the median, your number has to be listed in numerical order, so you may have to sort the list first. Mode. Mode is the value that occurs most often. If no number is repeated, then there is no mode for the list. Summary of properties of different central tendencies. The mean is not necessarily the standard measure of central tendency in statistics. It is the most commonly used. The mean is not necessarily equal to any score in the given set of data. The mean is the most stable measures from sample to sample. The mean is greatly influenced by outliers, which means that the mean will be strongly influenced by the presence of extreme scores. The median is not sensitive to outliers. The mean is based on all scores from sample, but the mode and median are not. The median is the best measure of central tendency if the distribution is skewed. The mode is the least stable measure from sample to sample. Mean, median, and mode. When to use. The following table shows the best measure of central tendency to use depending on the type of variable. If the variable is nominal, where there is an ordered and categories which are mutually exclusive and no ordering or direction, the best measure of central tendency to be used is the mode. For ordinal variable or those variable that are ordered or ranked or with scale and categories which are mutually exclusive, the median is the best measure of central tendency. For interval ratio, where data is not skewed, the mean is the best measure of central tendency. For interval ratio, where data is skewed, the median is best to be used. What is weighted mean or weighted average? In calculating a simple average or arithmetic mean, all numbers are treated equally and assigned equal weight. But a weighted average assigns weights that determine in advance the relative importance of each data point. A weighted average is most often computed to equalize the frequency of the values in a data set. For example, a survey may gather enough responses from every age group to be considered statistically valid, but the 18 to 34 age group may have fewer respondents than all others relative to their share of the population. The survey team may weight the result of the 18 to 34 age group so that their views are represented proportionately. In any case, in a weighted average, each data point value is multiplied by the assigned weight, which is then summed and divided by the number of data points. A weighted average is a calculation that takes into account the varying degrees of importance of the numbers in a dataset. In calculating weighted average, each number in the dataset is multiplied by a predetermined weight before the final calculation is made. A weighted average can be more accurate than a simple average in which all numbers in a dataset are assigned an identical weight. In a weighted average, the final average number reflects the relative importance of each observation and is thus more descriptive than simple average. It is also has the effect of smoothing out the data and enhancing its accuracy. Medians and quantiles. We often want to summarize a frequency distribution in a few numbers for ease of reporting or comparison. The most direct method is to use quantiles. Quantiles are values which divide the distribution such that there is a given proportion of observations below the quantile. For example, the median is a quantile. The median is the central value of the distribution, such that half the points are less than or equal to it and half are greater than or equal to it. The middle value of the sorted sample, middle quantile or 50th percentile, is known as the median. The limits are the minimum and maximum values. In other locations between these points can be described in terms of centile or percentiles. Centiles or percentiles are descriptions of quantiles relative to 100. So the 75th percentile, upper quartile, is 75%, or 3/4 of the way up an ascending list of sorted values of sample. The 25th percentile, or lower quartile, is 1/4 of the way up this rank order. Percentile rank is proportion of the values in a distribution that a particular value is greater than or equal to. For example, if a pupil is taller than or as tall as 79% of his classmates, then the percentile rank of his height is 79. Our next topic is measures of dispersion or variability. Why understanding variability is important. Let us take a step back and first get a handle on why understanding variability is so essential. Analysts frequently use the mean to summarize the center of a population or a process. While the mean is relevant, people often react to variability even more. When a distribution has a lower variability, the values in a dataset are more consistent. However, when variability is higher, the data points are more dissimilar and extreme values become more likely. Consequently, understanding variability helps you grasp the likelihood of unusual events. In some situations, extreme values can cause a problem. Frequently, we feel discomfort at the extremes more than the mean, understanding that variability around the mean provides critical information. Variability is everywhere. Your commute time to work varies a bit every day. When you order a favorite dish at a restaurant repeatedly, it isn't exactly the same each time. The parts that come off an assembly line might appear to be identical, but they have subtly different lengths and widths. Measure of dispersion or measure of variability. A measure of variability is a summary statistic that represents the amount of dispersion or the spread of data in a dataset. How spread out are the values? While a measure of central tendency describes the typical value, measures of variability define how far away the data points tend to fall from the center. We talk about variability in the context of distribution of values. A low dispersion indicates that the data points tend to be clustered tightly around the center. High dispersion signifies that they tend to fall further away. In statistics, variability, dispersion, and spread are synonyms that denote the width of the distribution. Just as there are multiple measures of central tendency, there are several measures of variability. Characteristics of measure of dispersion. A measure of dispersion should be rigidly defined. It must be easy to calculate and understand. It must not be affected much by the fluctuation of observations, and it should be based on all observations. Classification of measure of dispersion. First is an absolute measure of dispersion, and second is a relative measure of dispersion. An absolute measure of dispersion. The measures which express the scattering of observation in terms of distances. Example are range, quartile deviation. It is also the measure which expresses the variations in terms of the average of deviations of observations like mean deviation and standard deviation. A relative measure of dispersion. We use a relative measure of dispersion for comparing distributions of two or more datasets and for unit-free comparison. They are the coefficient of range, the coefficient of mean deviation, the coefficient of quartile deviation, the coefficient of variation, and the coefficient of standard deviation. These topics will be further discussed by the next reporters. And that is all for my report. Thank you for listening.